Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and AutomationNews.com. In this interview, I speak to Josh Cloer, Director of Sales at Mujin. Mujin is a company that's developed a system of programming robots of many different kinds, or brands at least, which is quite an achievement considering that each robot brand has its own way of programming and its own proprietary systems. Josh explains it all in the interview.
My name is Josh Cloer, and I manage sales and marketing for Mujin in North America. My background is actually coming from a company called Mobile Industrial Robots, and I was sales director there for a number of years. Helped them build out their sales channel here in the US with distributors and integrators. And before that, I was actually on the engineering side. So I have an engineering background, mechanical by nature, and deployed machine vision, 3D vision, robotics throughout my career, leading into my sales career. So that's me. A little bit about Mujin. So Mujin is a robotics technology company. So we actually were founded back in 2011. You can see our founders here in the upper right-hand corner of the screen. On the left, we have Issei Takino. He is our CEO. And on the right, we have Ross Dienkov, who is our CTO. And really the technology that has created this company is coming from Ross's PhD, his thesis for his PhD from Carnegie Mellon, where he actually developed a lot of this, the initial concept for the technology that has created Mujin. So really that was the automated construction of robotic manipulation programs. So really what Mujin does is automates robotics. So primarily 6-axis or 4-axis robot arms, and we are empowering robot arms to be more capable, efficient, and reliable. And we do that in a number of ways. But ultimately, our core product is the Mujin controller, which you can see down here on the bottom right, which is an industrial controller. That's where all of the software sits to create this new way of deploying robotics. So it's a controller, an industrial controller. It has ISO certified safety connections and an e-stop on the pendant and a modern interface on the pendant to deploy a robot arm. And also it can communicate to auxiliary equipment through Ethernet interfaces, GPIO, things like that. In addition, along the way, we found that you need more than just the control aspect to create an intelligent robot arm, and that's where we started to look into what is 3D vision capable of today, and that's really where the applications that this type of intelligent control fits within really started to blossom. So when you can use structured light and cameras to create a 3D point cloud to understand the space, that allows us to then operate within that space in a more intelligent way. So we've got some 3D vision aspects and also versatile gripping solutions. So we create standard solutions for different applications that we work within. And we also have the ability to make custom grippers. But really the technology behind the gripper is really where we're focused. So we have grippers that can do force torque sensing and vacuum sensing and independent channel control so that we can really have the most capable gripper, but also get force feedback and vacuum feedback so that we can kind of close this loop within the robotics control loop. So we can think, sense, and act. So that's really at a high level what we create is a more capable robot system, robotic system. And really, we actually work with every major provider of 6-axis robot arms out there. So we're not making our own robot arm. Where you know, robot arms are there's a lot of great companies out there that make great arms, and we are really working from their success and creating robot systems that are more capable. And we're doing that with no code through a model-based definition and motion planning. And ultimately what that allows us to do is manage variability on the fly. So it opens up new applications like piece picking, like mixed case palletizing, mixed case depalletizing, random metal bin picking on the automotive or aerospace side. So really anytime you have some type of variability that a robot needs to manage, that's what our system does really well. And that's what, you know, traditionally robotics haven't been able to accomplish. They're really good at doing the same thing over and over again. But when you throw some variability at them, that's where the traditional control techniques for robotics kind of break down. And that's what we're changing. And I'll see just one more thing on what are those control techniques. So the really basis for how to deploy our systems and how our systems work is this model-based definition. So describing what is around the robot arm, how does the robot arm interact within that space, what are the targets, what do they look like, where are they within the space, where's the vision system within the space, you know, how much shadowing effect are you going to have because of where the vision system is relative to where the target is. All of the physics behind the scenes is modeled as well. And that allows us to do motion planning, so real time real time motion planning, just determining each grasp point and each drop point to then find the best solution for the trajectory of the robot arm. So you're no longer teaching waypoints. You're no longer telling the robot, here's where you go. We decide that in real time. And ultimately what you get, it's probably a better video for this. This is probably a better video here. Ultimately what you get is like a digital twin. So our software here on the bottom right is mirroring, it is really driving the robot, but it is one-to-one the motion that you're going to see in the real world over here. So what that allows us to understand everything about the space and create plans for how to move an object from one location to another. So you get this very nice human-like motion. You get much more capability on how many grasp points you can have, and look at all of those to decide what the best one is. And also you can pack things very, very tightly. So that's really, you know, from a high level, obviously a lot of information there, Abdul, but that's really from a high level where we're coming into this space. We're bringing a new way of controlling robot arms and deploying robotic systems that's allowing for new applications in the logistics space, in the factory automation space, that manage, where variability is a key aspect that needs to be managed.
Mm. Yeah, very interesting, more technical than I kind of expected or usually kind of understand, but I did follow that, and you know, maybe I'll ask you to go back to one or two of the slides you were showing, especially the video. But first question I have, while you get that video lined up, because I've got a question about it. The quick question I have is, I thought all these robots had proprietary software, so the idea of having a third-party controller attached to them, like yours is, and having that controller control many different brands of robots, I didn't think that was possible. So I don't know if you explained it in your presentation, but how do you how do you achieve that? How do you make that possible?
Yeah, that's a fair question. So actually, you're definitely correct. So each robot maker has their own software that you learn to then create a program for the robot to do a task. Absolutely. And usually that is some sort of script language that you need to learn, and it's at the engineering level or the software level. Someone needs to spend a lot of time to learn how to do that and to create, beautiful programs that tell robots exactly where to go and exactly what to do. So that's obviously a key hurdle for users that now users need to jump over in order to actually deploy a robot. So typically what we see is they're hiring out someone else, right? There's an integrator that's a subject matter expert that has learned how to program a specific brand of robots, because it would be pretty laborious for the integrator to learn how to deploy multiple brands of robots. You have to learn a different programming language that's specific to the robot arm maker. So yes, that is a key burden right now. That's a limiting factor for how many robots can be out there in the world, because you have to have a subject matter expert that can program these for each one of these different brands. So we see that as a big value driver in the future, and honestly a trend in robotics in general is trying to lower the barrier of entry to robotics, right? So there's a number of companies doing this in a number of different ways. Some are making very pretty interfaces where you can kind of have this drag and drop programming that then builds that script language for you in the background. Others are in the same direction of us, really actually automating the building, kind of past the building of these programs. So we actually aren't using the script language for any of these robot makers. We actually look at the robot arm as a series of servos, and we actually go to the servo amplifier level. So we are actually telling each joint how to move in real time, as opposed to going through this filter of the robot programming language for each maker. So most of the makers out there have some type of real-time software offering, or somewhere where you can access each joint value to really control the robot more directly, which is obviously a very advanced way to control the robot. So it's not very commonplace that you use that in typical robotics applications, but that is actually how we control robot arms, is with the servo telling the servo amplifiers directly that are driving the servos, how to move in real time.
So let me share my screen and go to your website and carry on talking with you. I've got the gist of it, what you do, but it's very interesting to think that it is a new type of company. The idea of having a kind of controller that is a robot controller that is compatible with many different types of robots is a fairly new idea, really. I mean, so far over the years, over the many decades, they've developed, robot makers have developed very complex, as you were saying, proprietary software and all sorts of things. So the idea of it becoming interoperable increasingly is a very new thing. But because it's a new thing, companies like you, no matter how clever their solution and effective and workable, it's not going to be easy to find a market, is it? Quite quickly. I mean, you're a new company. I can't remember exactly when you were started, but how's it going for you, that part of it, the business side of it?
Yeah, it's actually going quite well. So we started over a decade ago, actually.
Okay.
We have really commercialized our products maybe 6 or 7 years ago, something like this. And we started in Tokyo. So that was a very strategic decision for us. We could have, started in Silicon Valley and raised funding and that kind of thing. But we've actually started in Tokyo because we see it as a great crucible for us. That's where many of the robot makers are, like Fanuc and Yaskawa and Enzo, and there are many. Most of the robot makers, quite frankly, are Japanese. So we got to learn a little bit about what they think about the robotics space and a little bit about where maybe we can fit within that. Also, the situation in the Japanese labor pool over the last decade, and really beyond that, there's really been this aging workforce where they've struggled to find the labor that they need to fulfill the demand that they have. So actually a great place for automation. And then on top of that, with what Toyota and others have done with like the Toyota production system mindset, creating this very quality, this high quality expectation within the customer base there. So we've had large demands on us from customers there that we have needed to meet, and also had some people to learn from in the robot makers, and a big appetite for automation there. So it's been a great launching pad for us. And actually, we've done a lot of business there. We're one of the largest robotics companies that are delivering logistics solutions, so solutions inside of warehouses and fulfillment centers there in Asia. And that has led us to our expansion here in the last year into North America. So we are we are right now in the middle of really building out our business operations here in the U.S. We started up in May of last year here in the U.S., delivering the products that we've already delivered, the solutions that we've already delivered in Asia to the U.S. market, tailoring them to the U.S. market. We've gone to our first trade shows here. We've had our first customers here. We've already deployed robots here. So in terms of finding a market, it's actually really, really great timing in terms of where the labor pool is and where we have this great resignation, or as I like to see it, really more of a great relocation, where people are taking on the new generation does not want to do these more manual tasks that you see within a warehouse or distribution center. And really there's the cost of labor is going up there, and really there's a huge opportunity for robotics and automation to actually have a big impact in warehouses and fulfillment centers, distribution centers across the world, and definitely here in North America, there's a huge need for that, and a lot of demand on that side. So I would say in terms of finding a market, we actually have solutions that are production ready that we've deployed across Japan and China that apply directly to any warehouse or distribution center across the world, really, and the demand is there. So I would say we're actually in a great spot in terms of where we sit in the market to provide solutions to the logistics industry.
Yeah, I didn't hear any numbers, but I suppose they're confidential. But yeah, I get the general idea. You're doing very well. Just another quick technical question, I suppose, about the controller. I've got it on screen. I think this is it. So you're showing it now with a different type of device. It doesn't look like a robotic arm. It looks like something with a camera or some sort of sensor at the end to detect positions of these boxes. The question I have is that how many robots can this one controller control? I mean, I don't know much about controllers, to be honest. I hadn't thought about it. Does a controller like this control just one robot at a time, or can it control more than one?
It's
And
designed.
is it different types of robots and devices that it can control? So, for example, robotic arms as well as what they call autonomous mobile robots, the mobile wheeled warehouse robots that you tend to see.
Yeah, that's a great question. So the controller is really built as the orchestrator of a robot cell. So it takes in all of the data and can tell everything how to interact. So that's really the high level. This robot controller is designed for really one controller to one robot arm. Uh, but it also connects to vision systems. So you can have multiple vision systems. So that's what you're seeing there. Is the vision system that we typically use for pallet loads, depalletizing, palletizing applications. And we actually use multiple different types of sensors for that application as well. So we kind of have some sensory data fusion, if you will, with 3D point clouds and 2D images and things like that. And so essentially our controller is really hardware agnostic. We work with any robot arm, we work with a wide variety of sensors. We can really work with any gripper that's out there as well. So essentially it becomes kind of the orchestrator of the robot cell. And you asked about vehicles, that's a great point. We see that there is a huge shift in the material handling side of things, how you're bringing pallet loads to and from robot arms, and we do interact with those types of vehicles as well, AMRs, AGVs. So absolutely, we can communicate to them. I wouldn't say we're at the levels where we're controlling how they're driving or doing any sort of like resource management or fleet management. However, we send information to those devices like fleet managers to say, hey, we need, this robot this vehicle that's holding, this order or this supply pallet, whatever it might be. So we can send orders to that type of system to interact with them.
Hmm. Yeah, I don't know much about much about the engineering side of it or the technology essentially, but robot controllers, an area that I need to, I suppose, learn a bit more about. So AGVs, what I was referring to, or AMRs. So
Yeah,
yeah,
and I would say ultimately we work with any, like, so you'll see AGVs here. We work with many providers there and can work with many providers, but we also have partnerships with a couple of companies in Asia where we can deploy some of these vehicles alongside them.
looks to me like this is a model that you're offering yourself. Mujin is offering to the market, or it will be, it says.
Right. So this is really a partner company that we're working with to deploy these.
Right. And the other thing I was thinking about while you were explaining about what your robot controller does or communicate, the kind of machines it communicates with. Nowadays, I've seen this kind of AMR or AGV with an arm attached on top of it. So there's a new type of robot, which I think is technically called Industrial Mobile Robot, IMR, which, I suppose that's something that you're going to have to account for or communicate with or something at some point. Yeah, it's a very interesting market. So how do you have any competitors? What's the market like? How is this particular type of hardware agnostic sort of, I think in networking they call it software defined networks, something like that, where the hardware, the proprietary software that goes with the expensive hardware is no longer in preeminence, as it were. So things are changing quite a lot. And as I say, although you've been around 10 years, it's still relatively new market, and although you're
Yeah, it
doing quite
is.
well, it's probably got a lot more potential than
There's a
maybe
huge
you've
potential.
realized. Hmm?
There's a huge potential because a lot of these applications that we're doing, to be quite frank, you couldn't do them before you had this type of control, because there was really no way to take all of these disparate systems, machine vision and gripper technology and robot arm and even AGV, and make them work together in a very nice way. It becomes a science project, and the ROI is way too is not there once you spend the amount of time you have to spend on it for a one-off project. But when you have this controller that out of the box can interact with all of these things, it creates a situation where you can actually get a return on your investment for some of these more difficult applications like mixed case palletizing and mixed case depalletizing, and it's definitely a new market, but there's a huge opportunity because retail companies, consumer packaged good companies, e-commerce companies all need these solutions. But there's not a whole lot of people that can actually fulfill it.
Hmm. Okay, final question. I notice on the website, in products and generally in our conversation, it's all about logistics and material handling, warehouses and things like that. Do you do any sort of manufacturing sort of based things in assembly or anything like that?
Yeah, we do. So if you go to products, and then actually that if you scroll off of that real quick, just the depalletizing, that application, that video that's playing underneath the screen there, at least it was on for a moment there. The container handling, that's a pretty common application in like an automotive facility. So depalletizing plastic containers that have replenishment parts that go to the assembly line, that kind of thing. But then if you go back up to the top, there are some factory automation solutions as well under the products section. So both bin picking and container depalletizing. So go to bin picking, that'll look more closer to what you're used to. It's still material handling, but it's in the factory automation setting. It's doing some bin picking and either interfacing with some machine, like machine pinning, or putting it onto some sort of conveyor for machine tuning down the line. So this is really where the variability comes in to manufacturing is on the inbound side. You might get a gaylord of metal parts that you have no idea how they look. So you need to somehow manage that variability.
Yeah, I was probably thinking about welding and joining and
Sure.
the actual, but I suppose material handling is a lot of assembly as well. You get a lot of robots doing assemblies. And
Right. Well, that's where robots already play, right? So since the 60s, you've had robots doing these assembly processes, and automotive primarily. That's been the driver for robotics. So while our controller can do that, there are companies out there that are built on, all we do is this specific process with robots within the automotive space. So the market there is actually more difficult to break into because it's a more traditional market that has solutions. And I would say our controller is capable of doing those things. We have done those applications early on before we, created this focus on the logistics side, really managing the variability, because that's where we see we can fulfill a big need that doesn't really exist in a lot of these applications. So our controller can do that. We focus on these applications because we can help get more robots into the marketplace generally by focusing on these applications. And then, down the road, ultimately what our controller does is makes it easier to deploy robots. And it's hardware agnostic. So it kind of, over time, as we build more awareness about what our product's capable of, that we will see more and more different applications, outside of the ones that we've focused on here.
Okay, Josh, thank you very much for your time and insights.
Absolutely. Thank you for having me.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.